Hello students, so let's perform this lab on deploying the smart contract on Sepolia using Remix. This is your fourth lab inside your blockchain subject of your engineering. So let's try this. First we'll try to understand what we are trying to do. So essentially we have an Ethereum network which is a test network, and this is called Sepolia, right? So since this is a Ethereum blockchain network, we can deploy our smart contract as a transaction into this network. So what we are going to do, we are going to deploy our smart contract over here. So this smart contract will have some transaction address and something like 0x something. So against this smart contract we will perform some operations. So the application that we are creating, we are going to use Remix ID. So this is a development environment, you can assume. So in this we are going to create a contract called Ballot. So what does the Ballot will do? It will carry out an election. So it will have functions like vote, and it will have proposals. So proposals basically means who all are standing for the voting. So let us assume in our case we will have an option of proposal 0, means option 1 who is standing for election, or maybe your choice. So I'll say we'll choose 3 cricketers: Sanju Samson, proposal 0. Proposal 1, Virat Kohli. Proposal 3, we will have Rohit Sharma. And if you don't want to vote any of the above, so you can select the 4th proposal. So this starts with the 0 and goes with 1, 2 and 3. So if we call a function proposals with 0, I should get the total number of votes for Sanju. If I say proposals for 1 total vote, I'll get the count for total votes given to Virat. In the end, I can announce the winner by calling the announce winner function. So this is my contract. It carries out a simple election in the blockchain network, and the blockchain network that I am going to use is Sepolia. So this is an Ethereum network, as I told you, and Ethereum supports smart contracts. This is Ethereum test network. Okay. So for this, whenever I want to carry out a transaction, I am going to carry out through a browser extension called MetaMask. So I'm going to have MetaMask browser extension. So this is your gateway. So if there is any transaction that is happening, it will go from here to here. So not all functions require transactions. Voting requires transaction. Proposals, like you want to know the total number of votes, that doesn't require a transaction. Every time a transaction is required, it will go through MetaMask. So in order to carry out a transaction, every transaction, we will have to have some gas money to carry out the transaction. It is like your transaction fee. So initially, you need to add Sepolia network in MetaMask, so that you can see whatever is happening here. So the currency that is used is Sepolia ETH. So initially when you are creating, so you need a MetaMask extension and a MetaMask account, and you need to connect to Sepolia. So initially this will be 0 ETH. So you have to go to a website which is something like cloud.google.com/something faucet Sepolia. So faucet is, you can assume for now that is right now this is 0 ETH, it means 0 ethers. So since you require to carry out a transaction, you will need to, somebody has to gift you some ETH. So we will go to cloud, so this particular website will gift you around 0.05 ETH. Every time you carry out a transaction, a little bit of your ETH will be spent. So in order to carry out your any transaction, you need this kind of an architecture. So in this we will have different students. So we'll say we will have different students who will participate in this election. So we'll have student 1, student 2, and it can go on till any number, student, let's say 5. So depending on how many students are there in the lab, you can perform this lab together. So student number 1 is actually going to upload what? Is going to upload your contract, and it will have the address. Then student 2 has to connect to the same, basically it has to use the same contract and do the voting. So student 1 will deploy and then vote as well. Now since you can vote only once, it will not allow you to vote one more time, because that's how the application has been written, smart contract has been written. Then the student 2 will vote, and maybe student 5 will also vote, or all the students will vote. So whoever is voting, they need to have a Sepolia account. They need to have a Sepolia account. So each student has to create a Sepolia Basically they have to have a MetaMask account, wallet MetaMask account, and each student has to add Sepolia network and add some ethers to it. Every time whoever votes will pay a little money for voting. So that's how it works. So all the voting result is stored with the smart contract as a state. You can say as a blockchain state. What is the state? Now the count is 0, then the count is 1, and so forth. So this is how the application works. So it's a little complicated, but that is how it works. So let us now go and see where do we begin with. As I said, so I have here two accounts, one account, and this is my second account. So here you can see this icon called extensions. In this I have added MetaMask. So you need to search for that extension, something like this, and you will get something like this, and you need to add. And right now since I added, it is already there. I can remove it as well, but I don't want to remove it because I need to use it. So that's how when I pinned it over here on the browser, so I can anytime open it and see it. Anytime the transaction happens, it will ask me for a confirmation whether if I should confirm the transaction. So MetaMask has to be installed. So right now you can see I have 0.0480 Sepolia ETH. So this was 0 ETH initially. So you need to create your account on this, create a wallet. Make sure you are connected to proper network. So here you can see the networks option. So in the network option, you need to enable test network. Once you enable test network, you will see all these test networks, and you can choose Sepolia. Now in order to add some money into Sepolia for your account, you need to click on this and say view all, and you can copy this Ethereum address. Okay, now once you have taken this Ethereum address, you go to this website cloud.google.com/application/web3/faucet/ethereum/Sepolia, and here you can, so if I click on this, it will say Ethereum Sepolia, give me your wallet address. So the wallet address that you copied from here, Ethereum, over here, something like this, you can go ahead and paste it over here and say get 05 Sepolia ETH. It will add that many ethers. This is your test this is your test network. So the money is not real, it is just used for testing purpose. So every student has to make sure the MetaMask account is created with a proper wallet address, connected to Sepolia network, and with some ethers added through the faucet. Okay, so let's see what are the steps. Install MetaMask extension, create an account, add Sepolia test network. You should see 0 Sepolia ETH, copy the Ethereum address, add some Ethereum into your wallet by visiting this website. You should see 0.05 Sepolia ETH. So now that we have done, now we can go back to Remix environment. So this account is going to deploy the smart contract. So as I showed you in the diagram, student number 1 will deploy the smart contract. Okay, so here you need some code, you need the contract, so Ballot. So this is my contract Ballot, and you can see the entire code, how the voting takes place, how the proposal happens. So you need to study, once you experiment, you have done the experiment, you should study this code, how it is written. So for now, the first step is I need to compile my contract. So here I am going to click, and I need to, so it says you need to connect to MetaMask Sepolia network. So okay, so you need to go to this option, deploy and run transaction. Before doing anything, you need to connect to MetaMask. By default, it will be connected to Remix VM Osaka. Now this option, injected provider MetaMask, will not be seen if you have not finished this process of MetaMask. You should see MetaMask, you can pin it over here, that extension should be there, otherwise this option will not come. If you have connected to your account in MetaMask, it will automatically load the Sepolia 11155.111 network, and you can choose this option. So you can choose this option. This will come only once you have finished all the previous steps of MetaMask. So this is student 1, and here I have, this is student 1, here I have student 2. The student 2 also has MetaMask installed. And the student also has some Sepolia ETH in. So don't be confused with the same name. This account belongs to student 2. So every student should have this kind of balance, or at least you should say 0.05 if no transaction has taken place. Okay, so now let's get back to our student 1, which is over here. So what I'm going to do, this is my file explorer, Ballot. So you need to download the code. You should not use the default code given by Remix. Instead you should use my code, which is over here, bit.ly/tcu student. Once you go here, click blockchain. Then click lab, then click code, and you will see lab number 4, Remix. So here you require 3 files, and one of the file is _ballot.sol. You require deploy with ethers.ts and ethers-lib.ts. You can open this code and copy whatever code is here into over here. So this is the code. So if you know, I have added winner announced, in case if there is any winner I can announce it. So every time announce winner will simply read the winner, based on the vote count. Okay. So then in the scripts folder also, as I told you, there are two other pieces of code. The main one is ethers-lib.ts will not change, but deploy with ethers will change. This is the code which will actually deploy your smart contract. So if you notice, it will, when it runs, it will automatically deploy your smart contract, and it will give you, it will return the smart contract address, and it will wait for the winner to be announced. Once the winner is announced, this event will be caught and you will see an output. Student 1 will see the output, who is the winner. Now this top screen is a code. Down as it shows you the log, so you have to click maximize whenever some operations take place. Now I'll clear this screen so that it is clean, and I'll minimize it. So first step is to compile your contract. So I'll click compile. So it has compiled my code. I can see the green tick, compilation successful. Okay, now I will go to deploy. I am going to deploy this on my Sepolia network. Remember that I am connected to MetaMask Sepolia network. So whatever I am going to run is going to deploy over there. So I'll run the script, and here, as soon as I run the script, it says deploying Ballot, and this thing opens up a transaction. 0.0011 charges is the network fee. You have to confirm this transaction, and it will try to deploy your contract to the Sepolia network. So it says Ballot deployed. So this is your smart contract address. Now this address is very important. So as soon as you do that, you see 0x54b, a new contract has been created. So we will open this contract, and all the functions that you have written inside the contract is exposed. Now I will ask proposal number 0, which is Sanju Samson. So if you really want to see the code, so ballot.sol, you will notice where is my script? So in the script I have added Sanju Samson, Virat Kohli, Rohit Sharma, none of the above in the proposals. So my election will begin with these options. I can choose any one for the election. So assume this is an election to choose the best favorite sportsman. So this has been deployed. So now what I am going to do, I am going to say proposal 0 means Sanju Samson, what is the count? So I am going to click on proposals, and it says vote count is 0. Right? Now I am the chairperson because student 1 is the chairperson because he or she has deployed the contract. So now I will put my vote to Sanju Samson, which is 0 index, and I'll say vote. So again a transaction is happening, the MetaMask will open, it is charging you 0.0004 ETH. So I'll confirm it, and once the transaction is over, so I'm waiting for the transaction to get over. So the transaction has successfully been executed, and now if I count proposal 0, it says 1. Now I need to connect to this particular contract. So I'm going to copy 0x54b by clicking the copy address. I'm going to go to my another account, which is second student. So I'm going to say, so you need to compile your code, have MetaMask even here. Only when you have compiled the code, this will appear over here, and all the functions can be seen. So to load my contract, this is a different address. 0xAA is a different address. This is not my smart contract which I just created. So I'm going to paste the smart contract 54b, and I'm connected to Sepolia, and I'm going to click add address. So 0x, so I'm going to close this, and 0x54b is created even over here. This is the student number 2. This was a James 38, you can see is my second account, and first account is 8 Labs. So there are two different accounts working on the same contract. So now that I've done this, I'm going to open up that particular smart contract, and I am going to vote Sanju, and I'm going to say vote. So it says, do you want to send the transaction? I'll say send the transaction. And once, if you're sending the transaction, that student, whoever is voting, will be charged a particular fee, 0.0123. So I'll say confirm, and this transaction is done. Now I go back to my student, the first student who is the owner of the smart contract, and I will say proposal 0. What is the count? What happened? Oh, something did not work. The transaction did not go through. Ballot vote is pending. What wrong did I do? 0x54b. Okay, do I need to compile again? So what I'll do is, actually I did compile before. So let me compile this. Let me go to deploy. The address is 0. Okay, maybe the permission is not there for the second student to vote. So that money is wasted because the transaction has happened, the money is wasted. So now I need to give permission to this account. So I'm going to copy this account, and I'm going to, the first student has to give right to vote. So give right to vote. So in that I'll go to address. 0x4c is the student 2 account address. I'm going to give right to vote. So again the transaction will happen, and I'll confirm that he has the right to vote, and the transaction will go through. So I've given the right to that other student to vote. You need to give rights to all the students, otherwise other students will not be able to vote in case if the rights are not given. So now I'll go to my second student. Everything is the same, the rights have been given to me, and I will try to vote again. I'll try to vote Sanju Samson which is at index number 0 vote. So it is asking to pay for the transaction, and let's hope the voting goes through. So this time the vote has gone through, and now I go back to my first student and I do a query, proposal 0, why it shouldn't show. Yeah, so proposal I didn't type in, maybe it wanted me to type in, so as soon as I put 0 and said click proposal, the vote count came to 2. And also I was initially, they took some time for the network to go back and come update, get the state, the latest state, and that's why the vote count is 2. Now if I want to announce a winner, student 1 can, even student 2 can announce the winner, but he is not going to see the output. I want to see the output on the console over here, so I'll say announce winner. So again the transaction will happen, and I'll confirm. It is trying to execute my transaction. And you will see a winner event emitted. Sanju Samsung is the winner. So now if you vote different people, it will announce the person with the maximum votes. So this is how an election can be conducted on the blockchain. So that is one use case. But the main important thing was how to use MetaMask, how to use Sepolia network, how to use Remix, and how to write your smart contract, and how to so ultimately you need your scripts to deploy your contract and run some functions. So your mini project has to be something similar based on this same architecture. Thank you.